Hi, welcome back to DivakDevelopers.com. Today we're going to talk with Russ, my plumber from Banana Mechanical. All right, we're going to talk about the heating system and then a little bit about the plumbing itself. This heating system in here is very intricate. It's all radiant heat everywhere. So that's under the hardwood floor, that's under the tile and everything. And there's a lot of different zones in here and there's really complicated stuff. Also, the boiler in here is direct vent and he's going to be talking about that. I want you to tell us, Russ, what this boiler is right here. Let's start out with the boiler first.
Well, this is a McLean Ultra. It's 96% efficient, very efficient. It means only 4% of the flue is going out the roof. The rest is staying in the house. It's low velocity, which means it only puts out anywhere from 100 degree heat to 180 degree heat. So depending on the outside temperature, this boiler will dictate what temperature to put out. So like today, it's putting out 126 degrees of heat. Now your normal boiler puts out 180 constant. This thing varies from 100 to 180. So you're saving tons of money that way.
And then direct vent, so right here.
Direct vent, not like the old flues, like an old chimney flue or an old stainless steel flue going out the roof. These are all PVC plastic. They just go out anywhere where there's no windows. This one goes out about 10 feet outside the house and just shoots out. Pretty
That's
simple.
great, so we don't need a chimney.
Saves you a lot of money right there. That stuff's a lot of money.
Pretty small too, compact.
Very compact, very light. The spoiler weighs about 100 pounds compared to about 1,000 pounds.
Wow, so these are over here, what are these things? These are
multiple circulars on this boiler. You got circulars pushing water into the boiler. You got circulars pushing water out of the boiler. You have separate circulars controlling the radiant heat. All this is computerized. We have a computer on the boiler, 2 computers on the wall. Everything
over here, so
yes.
These are computers, and what do they do?
These interact with the radiant systems. This also runs off of outside temperature. So this tells the radiant what temperature to run at. Now the max this radiant's called for is 130 degrees in this house. But this can vary from 100 to 130, which saves you money there too.
Wow, and all of this stuff, these are all
18 zones of heat, yes. 2 different water temperatures I'm running. This one calls for on max demand 115 degrees, which means this sensor here can run anywhere from 80 degrees to 115 degrees. This one can run from 100 degrees to 130 degrees.
And that all depends upon how cold it is in the house and outside.
And outside, exactly.
Okay, so how does that tell how cold it is outside?
This runs as a wire here that runs to an outside sensor, which also runs to the spoiler. One sensor controls everything. So they both interface with each other.
Wow, that's really cool. And then over here, this is expansion. What do we got?
Thermal expansion tank for the boiler.
What does that exactly do?
This takes the pressure. These boilers are only made to run, most heating systems generally are made to run under 30 pounds of pressure. So this has to eliminate some of the pressure that the hot water makes.
Okay.
You'll find this in every heating system. It's typical.
And over here we have, what's this? Our hot water system.
2 indirect hot water heaters. Again, runs off the boiler. They're not independently run like a natural gas water heater. So the thermostat on the hot water boilers or hot water heaters calls for heat, and what happens, it sends back a signal to that boiler. That boiler then fires up. These 2 circulars kick on, and it runs like a regular hot water heater, but you're not wasting that gas. These boilers, from start to finish, can heat water in about 12 minutes. So I can heat 150 gallons of hot water from 50 degrees to 140 in about 12 minutes.
That really works too.
That's outrageous.
And over here, I see what's all of this. These are all our tubings. What does that exactly do for us?
This is the radiant heat manifolds for the house. There's 18 of these in this house. They're pressure bounced. So what happens is the zone valve kicks on, boiler comes on, circulars come on, comes up to one of these manifolds. The manifold senses pressure and adjusts for each individual loop in the house. So it makes everything equal.
Wow, so we got a lot of those all over the house.
All over the house, yes.
Because all the tubing now is coming all out of there, and then that goes all on the floor, which we'll show you upstairs in a second. Oh, okay. So now, anything else that we should know about the system?
They're very complex, but very efficient.
So it works really well.
Very well, yes. Okay. What we have here is hot water recirculating line. Some houses we do every bathroom. In this house we didn't need to because of the way the plumbing worked out. What happens is, in some houses you have to wait to get hot water at your shower, to get hot water
Sure.
at your faucets.
From
Sometimes
afar
5
run.
minutes, yeah.
Because it's over on the other side of the house.
Absolutely.
And
This,
upstairs.
you'll have it within seconds at all faucets.
How does that work?
Well, we have a little pump, shoots water into the bottom of the water heater. Hot water comes out and it just makes a constant gravity loop. This is a time pump, so it comes on when you call for it. High demand situations, but it works fantastic. You don't have to wait.
That's the thing you always want to make sure that your contractor is doing.
That's what makes a mad customer a happy customer.
Exactly. I mean, because that happens a lot when you go in your bedroom, or I mean your bathroom upstairs. The master, what happens? You can't get hot water. You wait. Well, there's a recirculator will bring the hot water constantly, so you always get it. So that's a great thing to have.
This
Okay.
is almost, a lot of people don't want it, and I talk them into it constantly, and they still don't want it, and they regret it. They regret it instantly.
Divak developers, we make sure we put those in always, all the time. Let's go upstairs real quick, and I'll show you the radiant heat all on the floor and everything, what we did up there. Come on. Okay, here we are. Back upstairs now. If you want to look over here, we have a lot of tubes that are coming out of the ground. This is exactly right over where we were before, over the boiler itself. Now, Russ, why are there so many tubes if this is one zone in here?
Because we only want to put out a certain amount of heat per loop. So I can't run just one straight tubing back and forth, and there wouldn't be enough hot water at the end of the tubing to put out heat. So we're going to have to do it in stages. That's why that manifold on the wall is pressure balanced. So each one of these pipes represent one loop that goes about 150 feet. And down at the manifold, we have 5 separate ports. Each one's pressurized to the same amount of pressure. So every one of these pipes, these tubes on the floor, has an equal amount of pressure and gets an equal amount of heat at the same time, which is very important. If you run the lengths too long, the heat at the start of the tubing will be fine. By the time you get to the end, it'll be cold. You'll have a cold spot. Yes,
okay.
Absolutely.
That makes a lot of sense. So we have how many coming out of here?
We have five different loops on this one manifold.
And this is just one zone right
Just
here?
one zone, yes.
So there's one zone, we have 5 different loops coming just for the kitchen alone.
Exactly. This
Right.
equals about 1,000 feet of tubing right here.
Okay, because right here we have our wire mesh down that we lay, underneath our tubing for our tile. 'Cause it's all gonna be tile, and as you can see, it's a decent area that we are showing you. So that's what's running all there, and then we don't run. Why did we stay away from certain areas over here? Like why
Certain areas are low intensity heating areas, like the island. We don't like to run underneath an island because when you put the island down, they're going to screw into the floor. They don't know what a radiant tubing is. We're not going to run that. So we'll stay away from certain areas where we know we're going to put screws in the floor.
That makes a lot of sense. So that's great. So we have our island over here, and then the rest of our cabinetry here like
Yep.
this.
Yep.
Okay.
This heating system is designed by a computer. It's a computer generator design. It tells you how much heat you need per room. It tells you how much you need per heat per square foot. And that's the way this system is designed, by square foot and the heating intensity of the outside, what you need to heat this room with. So it's all computer generated right to the square foot.
Now with the computer, how does it is it like heat loss with windows, the height, how does that work?
Right. Well, the computer generates the radiant system. Say for this room, I need 115 degrees. That's what the radiant tubing needs to satisfy this room. But the outside temperature might be 50 degrees. So the computer on the boiler will tell you that, hey, I only need 90 degrees to heat this room. So that's what the boiler will put out to satisfy the heat demand of this house, because it's not 0 degrees outside. So it fluctuates. And this will heat at 80 degrees, it'll heat at 50 degrees, 70 degrees, but where you save your money is on the outside temperature. You don't want to heat the water to 180 degrees constantly. You want to vary it from 100 to 115 to 180.
Okay, so then the ceiling height, for instance.
Yes.
That
Everything plays a factor in your heat loss. Outside walls, the thickness of your walls, what you're insulating your walls with, ceiling height, square footage of the room, volume.
So you put that all in.
All that
and it
goes
tells
into
you
the computer
everything.
and it generates this design, yes.
All right, so this is our kitchen, so this is our floor. I just want to show you real quick over here. This is going to be all hardwood floor. What they're going to go with the gypcrete. So this is what they're all sleepers down here, if you can see. That's all wood that's laid in between. So we don't have any wire mesh down here, because then our wood's going to go right on top of that, and it's going to come up and be a really good heating system there too.
This is a fantastic heating system for oak floors. Wood sleepers to nail your floors onto, and then concrete or gypcrete in between them. You can't get a better source of radiating heat is a cement-like product. So nice warm wood floors, walk around in your bare feet. Everyone knows how cold it is without it. Wood floors are, and these are gonna be toasty warm.
That'd be great. So, and the rest of the plumbing, because Russ did all the rest of the plumbing, as in, you know, our water lines and our waste lines and stuff like that. I mean, it's very simple. If you have any questions, don't hesitate to call me at divacdevelopers.com. And I'll answer all your questions, and we'll show you that at the end. Thanks, Russ. Thanks, I really
Thanks, Mark.
appreciate you telling me all this stuff. And again, thanks for watching.